The universe is vast. It's almost, well, incomprehensibly big. Our galaxy, the Milky Way, contains hundreds of billions of stars, and there are hundreds of billions of galaxies just like it. Many of these stars have planets orbiting them. Scientists now believe there could be trillions of planets in our galaxy alone. With so many potential homes for life, a simple question arises. It's a question that has puzzled scientists and dreamers for decades. Where is everybody? This isn't just a casual curiosity. It's a profound scientific mystery. We've been listening for signals from the cosmos for years. We've pointed our powerful telescopes toward distant stars, hoping to catch a whisper, a sign, anything that proves we are not the only intelligent beings out there. But so far, we've found nothing but silence. This profound silence is often called the Great Silence. It's a strange and honestly kind of eerie quiet in a universe we expect to be noisy with life. Think about the numbers again. If even a tiny fraction of those trillions of planets developed life, and a fraction of that life became intelligent, the galaxy should be teeming with civilizations. Some of these civilizations would likely be much older than our own. They would have had millions, or even billions of years to develop technology far beyond our comprehension. They should have spread across the stars. Yet, when we look out into the night sky, we see stars, planets, and galaxies, but no clear, undeniable signs of intelligence. This puzzle has a famous name, the Fermi paradox. It's a paradox because the logic seems sound, but the conclusion doesn't match our observations. The universe should be full, but it appears empty. Why would an entire civilization choose to go silent? The reasons might be rooted in the most fundamental instinct of all, survival. The universe can be a dangerous place, and an unknown neighbor might not be a friendly one. This idea is powerfully captured in a concept known as the dark forest hypothesis. Imagine a dark forest at night. It's full of hunters. Every hunter is a potential threat to every other hunter. To survive, you must stay silent and hidden. If you make a sound or light a fire, you reveal your position to everyone else. The safest strategy is to assume everyone else is a threat and to eliminate any other life you find before it can eliminate you. There is another reason for hiding that is less about malice and more about caution. Contact could lead to a pandemic on a scale we cannot even imagine. We worry about viruses from Earth's own jungles and melting permafrost. Now think about a microbe from another planet, one that our immune systems have never seen. It could be an extinction-level event, a cosmic plague that wipes out an entire biosphere. This concept is sometimes called planetary quarantine. An advanced civilization might understand this risk perfectly and enforce a strict policy of non-interference. What if civilizations hide for ethical reasons? A highly advanced society might develop a profound moral code regarding less developed worlds. Contact could irrevocably change our culture, our science, our religion, and our entire path of development. If a vastly superior alien race revealed itself, humanity's own ambitions might just collapse. Why strive to solve problems when a galactic supermind could just give you the answers? They become cosmic guardians, protecting our right to make our own mistakes and find our own way to the stars. This kind of hiding is not born of fear, but of principle. The simplest way to hide in the cosmos is to just be quiet. For a young civilization like ours, this is almost unthinkable. We are noisy. We leak radio waves into space constantly. Instead of broadcasting signals in all directions, they would switch to highly focused directional communication systems, like tight beam lasers or fiber optic networks that contain all their information. For a civilization that has existed for millions of years, this would be second nature. Their technology would be designed from the ground up to be efficient and silent. The next level of hiding involves actively camouflaging an entire world. One way to do this is through atmospheric manipulation. An advanced civilization could deliberately alter the gases in their atmosphere to mimic that of a dead planet. They could pump in gases that create a thick, opaque cloud layer, permanently hiding their surface from view. The civilization would live underneath this artificial sky, perhaps using artificial light to sustain their ecosystem. They could build a network of orbital mirrors or light-absorbing materials. These could be adjusted to change the planet's apparent color and brightness, making their world appear much darker or mimic a different type of planet. For a truly advanced, energy-hungry civilization, hiding a single planet might not be enough. Instead of one single solid shell, a Dyson swarm is a massive collection of smaller independent orbiting habitats and power collectors. The key to hiding a Dyson swarm is heat management. They could build enormous radiators, miles and miles long, that are painted black and pointed away from the galactic plane, where fewer eyes are likely to be looking. This transforms the star system into a fortress. They have all the energy they could ever need, but from the outside, their system looks quiet and unremarkable. Ultimately, all hiding strategies face one inescapable enemy: heat. The laws of physics are unforgiving. Every action, every computation, every form of life and technology generates waste heat. A civilization could build vast radiator panels, far larger than their habitats themselves. By spreading their waste heat over an enormous surface area, they can radiate it at a very low temperature, maybe just a few degrees above absolute zero. Their heat signature would then blend in with the faint glow of the cosmic microwave background, the leftover radiation from the Big Bang itself. Consider the challenge of gravity. A planet, a star, or a massive Dyson swarm all have mass, and mass bends space-time. You cannot hide gravity. Even if a civilization cloaks its system from light and heat, its gravitational influence remains. Then there is the problem of maintenance. A cosmic camouflage system would be a megastructure of unimaginable complexity. Over thousands or millions of years, the probability of a significant system failure approaches certainty. Finally, there is the simple fact that you cannot control everything. The universe is a chaotic place. A stray comet could crash into a hidden habitat, causing an explosion of light and heat. A civilization trying to hide is playing a game of perfect defense, but an observer trying to find them only needs to get lucky once. A single catastrophic event could undo eons of careful hiding. Imagine a war between two factions within a hidden Dyson swarm. The use of powerful weapons could shatter habitats and destroy parts of the heat management system, releasing a massive burst of energy. The resulting explosion could be as bright as a supernova, shining across the galaxy for all to see. It would be a beacon of failure, a tombstone visible across light years. If advanced civilizations are successfully hiding, then looking for their bright signals is, well, kind of a fool's errand. So how could we find them? We would have to become cosmic detectives. We'd need to look for the indirect evidence, the subtle clues they might leave behind. We wouldn't be looking for the civilization itself, but for its shadow. We would search for the strange little anomalies, those data points that just don't quite fit our models of the natural universe. A perfectly hidden swarm might radiate its heat so effectively that it blends in with the background, but it would still block some of the starlight. Astronomers could systematically survey stars, looking for those that are unusually faint. Another indirect clue could be found in the chemical composition of a star's atmosphere. A very old civilization might have been cleaning its solar system for eons, mining out most of the heavy elements from their asteroids and inner planets. We could also look for things that are missing. What if we find a region of space where there are far fewer black holes than our theories predict? It could be a sign that a super-advanced civilization has been harvesting them. This leads to the idea of archaeological SETI. Perhaps we will never find a living, hiding civilization. Instead, we might find their ruins. We might find the evidence of a civilization that tried to hide but failed. We might detect the faint, decaying heat signature of a long-dead technological world. Our first contact with alien intelligence might not be with living beings, but with their ghosts. We would be cosmic archaeologists, piecing together the story of a lost civilization from the echoes of its accidental exposure. The greatest weapon in the search for hidden civilizations is time. A stealthy civilization has to maintain its cloak continuously, but astronomers can observe a target for years, decades, or even centuries. Over thousands of observations, tiny variations can be averaged out, revealing an underlying pattern. Nature is messy. Perfect, unchanging consistency can itself be a sign of technology. Time also allows an observer to see a system from multiple angles. Over thousands of years, this change in viewpoint could reveal something hidden behind another object. Ultimately, the contest between hider and seeker is a race between technology and time. As our own technology improves, our ability to detect faint signals and tiny anomalies will grow exponentially. Things that are perfectly hidden from our current instruments might be glaringly obvious to telescopes a century from now. A civilization that went into hiding 1,000,000 years ago would have had to predict the technological capabilities of every potential observer. Time is on the side of the searcher. We just have to keep looking and keep getting better at looking. Eventually, time can wear down even the most sophisticated cosmic camouflage. But this exploration of the cosmos inevitably leads us back to a mirror. It forces us to look at our own civilization, humanity, standing at a pivotal crossroads. We are the noisy toddlers in the dark forest. We are shouting our existence into the void with every radio broadcast and space probe we launch. The question is no longer just where is everybody, but also what should we do? This is no longer a question for science fiction authors alone. It is becoming a genuine debate among scientists, philosophers, and policymakers. Do we continue our current path of broadcasting our presence with youthful abandon, hoping to find friendly companions among the stars? On one hand, the desire to connect is deeply human. We are a social species driven by curiosity. Or do we take the Fermi paradox and its darker solutions seriously? Should we begin to consider a future where humanity deliberately lowers its profile, embraces radio silence, and values discretion over discovery? The argument for caution is rooted in the simple, brutal logic of risk assessment. The stakes are unimaginably high. If we are wrong about the friendly nature of the cosmos, the result is not disappointment. It is extinction. It is a decision with consequences that could echo for millennia, defining the ultimate fate of our species. The debate has two powerful sides. To intentionally silence ourselves could be seen as an act of cosmic pessimism. The proponents of a more careful approach suggest that we should listen, quietly and carefully, for a long time before we ever consider sending a deliberate, powerful message. We should learn the rules of the cosmic neighborhood before we announce our arrival. This isn't about giving up on connection forever, but about ensuring our civilization survives long enough to be ready for it. The question remains, are we bold explorers or careful survivors? As we stand on our small world and gaze out at the star-dusted darkness, we are left with a profound sense of wonder and uncertainty. Is the silence a sign that we are truly alone, the first and only minds to ponder the stars? Or is it the carefully maintained quiet of a universe full of ancient wise observers practicing a strict prime directive? They might be watching us right now, patiently waiting for humanity to outgrow its violent adolescence. Then there is the most unsettling possibility of all. The dark forest. Is the silence the sound of fear? The collective held breath of countless civilizations hiding from one another in a universe where detection means death? Ultimately, we do not know which of these realities is our own. We are left to wonder. Is the universe a lonely cradle, a patient classroom, or a deadly arena? Are we alone? Are we being watched? Or are we being hunted? The search for extraterrestrial intelligence is therefore more than a scientific quest. It is a search for our own context. As we continue to listen, we must also consider what we will do if we find something, or if something finds us. The silence of the universe is a mirror, reflecting our greatest hopes and our deepest fears. The final answer is still out there, waiting in the vast, quiet, and mysterious expanse of the final frontier.